All right, folks. Thank you all for being here. Welcome to February. It definitely feels like February. Nice and cold. Is this colder than last month? Last month we were really scared people wouldn't show up because how cold it was. I think it's even colder today. So thank you all for being here. Know that the cold doesn't keep you away. We're all New Yorkers. We all have to brave the elements to get anywhere. So I'm very glad everyone's here. So the very first thing we always do at this meetup is ask, who's hiring? All right, so who has a job they want to post? All right. Stand up and announce it. Let everyone see you.
Right. Hey guys, I'm John. New to the group, but excited to be here. I actually don't come from the data science world.
So this way you're on camera. Nicole, I'm having him move. This way I don't have to move.
Fantastic. All right.
I'll put my mic near you, so
even better.
It'll pick you up. Don't worry.
Great. So I actually don't come from the data science world. I come from the food world, and so I'm actually now working on a new project that is basically building an AI-powered health technology company where we will be designing and delivering very nutrition-targeted meals and meal plans through the use of kind of an AI data science recommendation engine that we are building. So I am here looking, I'm kind of starting a search to hire kind of a founding AI engineer, data scientist onto our team who can really help build this this recommendation engine where, our goal is, we want to kind of start with a baseline of general nutrition science where we're gathering information on each user and developing like very targeted meal plans for them personally and to align with whatever their health goals are. And then we want to get as many data inputs as we can, whether it's from biometric data, Apple Health, Oura Ring, sleep trackers, fitness trackers, glucose monitors, blood work, and as much data as we can get in on a person. We want to incorporate it into our model so that we can really make the most targeted recommendations for what's going to be best for their health and their goals and longevity. So if that's really looking for somebody who not only has the background, the data science background, knows how to work with some of these large language models that we want to leverage, and also just has a genuine passion for health and health science and nutrition and longevity. So if that sounds like you or anybody that you might know, please reach out to me. I'm sure.
How do they get in touch with you?
Can I share my email?
It's up to you. If you want your email out, go out on YouTube. It's on YouTube though, so anyone watching this on YouTube.
Okay. Yeah. Happy to share my email through the group. Jonathan.a.sherman@gmail. And then we can have Jared kind of distribute to the group as well.
Right. But, that's on YouTube now, so the whole world has your email.
I already get so much spam.
Okay.
It is what it is.
All right, cool. And did you post it on the job boards?
I have not posted it yet, but post will be incoming.
All right. So go to that email. People watching at home, people here, go to the email. We're going to the bar afterwards. If you're in person, find them there. But apply for a job.
Thank you, guys.
Anyone else hiring? Oh my God, 2 in one day. We haven't had this since before the pandemic.
Okay. Hey, Mike is...
Just project. It's on me, so just project.
Okay, cool. Hey, what's up? I'm Andy. I'm a data scientist with Grow Progress. We're a progressive firm that helps our clients who are candidates, campaigns, large PACs, progressive organizations, find and test their messages. So we also are expanding to the corporate side of our business, and so we're hiring a senior research strategist. So this is a role for someone with a little bit of technical expertise, but who really enjoys helping clients take all of those quantitative inputs, so survey experiments, polling, other modeling we do, and help them understand how to better message and talk to their audience. Comp is like 100, 125K plus equity. You can find the job at growprogress.ai. I'll post it in the job board, or if you're here tonight, come talk to me. Thanks, y'all.
Okay. All right. Can we go for 3? No? No one else hiring? Someone just give someone a job just so we set a record for post-pandemic. Before the pandemic, we'd have like 7 people hiring. It was great. Okay, so no one's going to hire outside that. But we got 2 at least. That's progress. We'll see what happens next month. All right, so now the job's out of the way. The most important part of the meetup, the pizza. This month's pizza came, yep, some of you are already reaching. I love it. This pizza came from Andiamo. Go on your phone, bit.ly/pizza poll, and rate it. Those of you that are new, for like 12, 13 years now, we've been tracking the pizza. Every month, people rate the pizza. We have a live bar chart on our website. So go there, get out your phone. Come on, pull out your phone, rate. bit.ly/pizza poll on a scale of essentially 1 to 5. Let us know how the pizza is, and this goes into our data feed. The data is freely available, I think, at jaredlander.com/data/pizzapoll.php, unfortunately, but it's a JSON feed. It's a JSON feed that's generated by PHP. I hacked it together 8 years ago, and if I touch it, it'll break. So just go ahead and get that. If you go to nyhackr.org, and click on more than pizza, you'll see a live bar chart written in JavaScript for some reason, which I have to be, I guess. Yep, there you go. And do you want to rebuild it? Because George has some ideas that he needs to make it more of a multi-level model, and you can rebuild the viz. See how that just happened? You two got volunteered. Good, good. You show enthusiasm, you got to do stuff. So let us know how the pizza is. This is very important to our sampling here. All right, we have a request from someone not here. A lot of you know Noam Ross. He spoke. Thank you. No, it doesn't say he spoke at the Meetup repeatedly. Fine. He has given many talks at the Meetup and at the conference. He works with our OpenSci, which is a great organization which does a lot of good open source efforts for the R community. They got gifted by a defunct organization 3 small servers about the size of large desktop computers. They're looking for somewhere to put them that they could plug it into the internet, and they'll use, they don't need it. I don't think they need any holes in the firewall. They could just, use software-defined networks. But they're looking for somewhere that they could stash these machines, keep them powered on, keep them connected to the internet. So if anyone has the ability to stick it under a desk at work, or has a company that's willing to share space, whatever it may be, or in your house, let Noam Ross know. You can get in touch with him. He is on our Slack, on the nyhackr Slack. You can get in touch with him there. Or maybe he'll be here next month. He comes usually. But find Noam Ross from our OpenSci. He's on Blue Sky. I'm sure he's on other services. He's on LinkedIn. He's on our Slack. Go in there and help him out. This would be a great contribution to our OpenSci, which is a nice part of the community. So help out Noam Ross. We all love Noam. All right. Speaking of Slack, we have a Slack for the Meetup. Some of you are new. Some of you are old. Those of you who are old probably know about it. But those of you that are new, go to nyhackr.org and find the link for Slack. Those of you at home, if you have a question from the speakers, you obviously can't raise your hands. So if you post it in the Slack or in the YouTube chat, I will collate the questions and ask it of the speakers at the end. People here, ask questions yourselves. All right. Speaking of people watching from home, you all know that we have Andiamo Pizza, and it's awesome. Well, I'm not sure, but New York City is awesome for pizza. Wherever you're coming from, let us know what you're eating. If you're coming from Chicago and you're having a casserole, let us know. If you're from anywhere else, let us know what you're eating and just chime in, be a part of the conversation. All right. Next up, March, we have Vikram giving a talk either about modeling social networks or about chaos and machine learning. He said he's going to choose, but we think we could all influence him. Who wants social networks? Who wants chaos and machine learning? There's like a verbal, audible gasp. So do your best, Ian and Malcolm. Vikram, you're probably watching from home. I don't know why, because you live right near here. Get over here and come give a talk about chaos next month on chaos and machine learning. April might be Eric finally giving that Pixar talk. Those of you that know, a few months ago, Eric thought he was going to give a talk about Pixar. Then he realized he couldn't because his company wouldn't let him. And at the last minute, we had Daniel Lee sub in for us, which was super awesome. We're hoping Eric can give the talk in April. But if not, our May speaker, Garo, will be ready to fill in. Because Garo will either be April or May, depending what happens. What's your talk going to be about?
Graph theory, linear algebra, something cool.
Graph theory, linear algebra, something cool. All right. So we have through May mostly lined up, maybe a few moving pieces. We probably still need June, July, and August. So anyone who wants to give a talk, raise your hand or come up to me later. If you're in line, send me a message on Slack or email or LinkedIn or anywhere you can find me. Or I will start pointing at people and making them give talks. There's some regulars here who have not given a talk for a while. Actually, where's Gerald? I keep harassing him. Frank, you're going to give us a talk at some point.
I was going to say, I'm not Gerald, but yeah.
Yes, well, that's like I said, Frank. You owe us a talk. All right, so, and other people too, I will call on you randomly as the months go by. I just did it to Garo today, right? Actually, I did it to you a month or two ago, but I reminded you today. Okay, I want to take a very quick moment, not a very quick moment, a very long moment to thank George from NYU for making this happen month after month. George has given us our consistent home here at NYU for over a year now. And that consistency has been so helpful, not just in that we have a place to go, but also just been so helpful in setting it up and making sure the internet works, making sure the screen works. So again, seriously, George, another round of applause for you, because you've been awesome. And for George, afterwards, we were going to the bar. We were going to Malt House by his personal request. All right, we went there last month, Malt House. I think it was really popular. People liked it. They had some really good beers. Sometimes they come in mason jars. I don't know how you feel about mason jars, plus or minus. But it's a good bar. It's not too loud. And it's only a 4-minute walk, I think. So
We'll call it 7.
Is it 7?
Yeah.
Set 4 to 7 minutes. There's a confidence interval. All right? So 4 to 7 minute walk. We'll get there. It'll be awesome. All right?
Thompson Street.
Thompson Street. Thompson and what?
Close to Bleecker.
Close to Bleecker. Below or above?
Above.
Okay, above Bleecker. So it's not that far. All right, so we'll make it there. Everything will be great. If there's any pizza left over at the end of the night, you know the rule. We can't leave until everyone's finished the entire box of pizza. All right, there can be no pizza left over at the end. Important rule. All right, so everyone remember this. We have the next few months planned. I need more speakers. We're going to Malt House, and you're going to ask questions in the chat. Everyone sound good? All right, then I am very excited about this next talk. This is like our second, is this our second MTA talk? Yes, I think it's our second MTA talk. I saw this get posted somewhere. I remember I saw it on some website. I thought it was awesome. So I immediately reached out to our speakers and said, hey, you gotta come give a talk here. I'm really excited about this talk. I love maps. I love the I tolerate the subway. We all have to ride it. It used to be awesome. Maybe it'll get better again. So everyone, please welcome what I hope is going to be a very exciting talk about the subway maps, Jediah and Marc.
Hey everyone, thanks for being here tonight. I'm Jediah, and this is my partner Marc. I also want to acknowledge our other partner, Julia Hahn, who's not here tonight, but who did a lot of the design work for this project. So we're here to talk to you about Subway Stories, which is a project that combines this interactive visualization of where people are coming and going in the New York City subway with 5 journalistic stories that follow a different demographic of people as they move through the subway. And we use the MTA, their open APIs to actually get this data. This is 2023 data because we made this before 2024 was over. We wanted to have a full year of data, but now 2024 is over, so we probably should update it with the latest data. And we made this for the Open Data Challenge, which is the first ever competition hosted by the MTA that invited people from all over the city to make something cool using their open data. And we got honored as the most creative submission for that competition. And we got to give a really cool talk at the New York Transit Museum, which was way less technical than this one's going to be. And we even got shouted out by the Manhattan Borough President. So that was really cool. I'm going to pass it over to my partner, Marc, who's going to talk a little bit about what the project is in more detail, some of the design decisions behind it, and then I'll talk to you later about the engineering and deployment. So go to Marc.
Thank you, Jediah. Yeah, so like Jediah mentioned, I'm going to go over some of the UI and design choices and also just kind of walk through the project and show the different features and functionality that we have. So first, I'm just going to describe the data set that we used a little bit. So this was a pretty unique data set that paired 2 swipes from a single Metro card or Omni account to estimate a trip in the subway. So basically, if let's say, for example, a rider swiped in at Times Square at 8 a.m. and then at 5 p.m. that day, they swiped into Fulton Street and there were no rides in between. That was estimated as a trip at 8 in the morning from Times Square to Fulton Street. Obviously, these estimates aren't perfect. People may have walked to a different stop somewhere throughout the day. They may have taken a bike or a bus, but we got a pretty good estimate of large-scale movements of people throughout the subway. So while we were developing this project, we wanted to include an explore mode and a story mode. When we were first delving into the data in this, we spent a lot of time sifting through, looking for trends, trying to figure out good stories that we could include in this project. One story that we were really proud of was what we called the Tale of 5 Chinatowns. And that's a story that I'm going to go into in a little bit more detail now and demonstrate. So when we were first going through the data, we noticed a large amount of people going from Bensonhurst and other parts of Brooklyn into Chinatown and Lower Manhattan at pretty early in the morning on a Saturday and Sunday. And we weren't really sure why this was happening, but we noticed it in the data. After we talked to a couple friends that lived in Bensonhurst, we learned that a lot of young Chinese Americans go visit their family and go enjoy a meal in the morning. But what you're seeing here So these are all the arrivals to Grand Street at the BD stop in Grand Street, right in the heart of Chinatown at 8 a.m. on a Saturday morning. And each of these bars down here represents a certain amount of people that got on at each stop at that hour. So that was estimated basically using, someone swiped in at around 8 o'clock at 71st Street on the D, and then their next swipe, maybe a couple hours later, was at Grand Street. And yeah, this is basically the sum of all of those pairs for each stop. I think it's pretty cool and worth noting that you can see stories that are relatively smaller scale here, at least when compared to the volume of 4 million people that take the subway on average every day. If you look at some of these ridership numbers, most of them are less than 50. But I think it's pretty cool how clearly visible this is, even at a relatively smaller scale. Another story that was much larger in scale and is maybe one of the more obvious ones, but in my opinion is still one of the more interesting ones, is the story of how New York City works. New York City has an enormous economy. If it was a country, it would have the 10th largest economy in the world. And it's pretty cool to see where people come to work, how they're getting into work, where they go, and then their commute home. So first, it's really cool to see how many people are coming from out of the city into work. If we look at these huge transportation hubs like Penn Station, you can see the truly enormous volume of people that come in at 8 a.m. on a Wednesday. It's over 7,000. Grand Central, even higher, closer to 10,000. And then the largest spike is Port Authority. I was actually commuting there, going the other way while I was going to do some work in New Jersey for a while, and I was really mind blown by the amount of incoming traffic. So I thought it would be cool to include that in this project. Yeah, so like I mentioned, there were a ton of people coming in, but it's also cool to see where they're going to work once they get into the city. So now we're looking at departures. So people that probably got off the train or bus and then tapped into the system and then went to work. So we can see a lot of people going down to work at Fidei, Chamber Street, Fulton Street, somewhere over here. And then also a lot of people working in this, kind of Midtown East business district with a lot of office buildings. You can see, there's a lot of traffic there. And you can also see that it's not just out of city commuting. If we look at this area in more detail, there's a lot of people commuting from up in Yorkville, which is one of the most densely populated neighborhoods in the city. There's people coming from all over Queens, as far as Flushing, Jackson Heights. So yeah, it's really cool to see how everyone gets to work and where they're coming from and where they're working. So while this was really cool, we also felt strongly about including an explore option, which is kind of like the free play mode of this project, if you will, where you can basically pick a station, any station, pick a day, pick a time, pick if you're arriving at or departing from. And it's really cool that you can see kind of as you slide through, you can kind of see this like breathing or like heartbeat kind of effect of people going to work during rush hour and then coming home at the end. So how do we find good stories? I'm going to give a little bit of detail about how we found good stories because I think it's kind of a nice blend of data science and also humans and people. So many stories, the inspiration for some stories came from our own experience. Like I mentioned, I was commuting to New Jersey for a while and was surprised with the amount of volume of people. So we were interested in doing a story about commuters into New York. My friends and I have been to the US Open and other events at Flushing Meadows, and we always noticed the large amounts of people these crowds drew, so we thought it would be interesting to do a story about that. My friends and I often go out, somewhere along the L train, either in Williamsburg or Bushwick, and we wanted to see if our nighttime adventures were reflected at scale in the data. They were, so that's another story that you can find in there is about nightlife along the L train. Obviously, this is where the inspiration and kind of the ideation for these stories came from, but it was the data at scale that made them legitimate stories that we were happy to include in our project. Some stories were definitely more serendipitous. The tale of like the Chinatown story I shared, we were playing around in explore mode, and we noticed this, and then we kind of, delved into more detail, looked at it more closely, and then started talking to people that we knew that lived in those neighborhoods. And that's how that story came. We also have a shift about weekend workers and weekend commuting and which neighborhoods have more people that are working on the weekend. And that story came about totally by accident. We were working on a different story and noticed a large spike of outgoing traffic in Jackson Heights at like 4 in the morning on Saturday. So I went down and started talking to some people that worked there. I actually talked to a bunch of the local street vendors down there and said, hey, is this a really high density commuting neighborhood on the weekend? And they talked to me and they were like, yeah, there's actually a great deal of people going to work in the weekend. So that eventually, we added more to it, but that eventually became the weekend shift story. So I hope that was a nice kind of intro to our project and give a little bit of context of how it was structured. I'm going to go into a little more detail now about the visualization and design choices and some of the UI features that you'll see in this project. So first and foremost, we wanted it to be able to distinguish between arriving to and departing from. Sometimes at first glance, this isn't always obvious, but as you can see, here you have the option, let's say arriving to, departing from. That's how you switch. And you'll notice when I just did that switch, the kind of wave was emanating outward, which is a nice way to indicate. And also, if you look at this here, you can see it's kind of pulsing away, which I think, in my opinion, is the clearest indication that this is a departure from. When I switch back to arriving at, you can see it kind of all converging on that. And also, the dot is going in towards the stop, and the color is blue versus a green for emanating. We also have, you may have noticed as I was playing around with stations, we have an all stations mode versus kind of a specific origin destination mode where you can pick a specific station that you're interested in. So if we go to all stations mode, this is kind of what it sounds like. You can scroll through the time and just kind of, again, see that really cool kind of pulsing effect of where people are going, what times they're going, what the busiest stations are, where they're coming from. And yeah, if you scroll through the day, you can kind of see everybody waking up, the big morning rush hour, the kind of lull in the midday, and then the big spike for rush hour again when people are going home from work. So you've probably noticed by now, one of the most identifiable things is there's a difference in bar color and bar height in both based on which station you're at and where you're coming from and where you're going. This was one of the more technically challenging aspects of this because we needed to figure out some way to normalize the bar height so that all stories were clearly visible regardless of scale. You'll notice some configurations, like the Chinatown story I shared, had a really low volume over the day. I think almost all of them were less than 50. And then some, like those workday commutes, were upwards of 10,000 in some stations. So we needed to figure out some way to normalize this. To do this, we picked one day kind of as the default frame of reference and use a dynamic scale proportional to 1 over the maximum amount of people at any station in the day. So basically the tallest bar across the day, the tallest bar would be constant across the day. And this prevented some stories from being so small they were practically invisible and others from being so big that they go off the screen. I'm going to demonstrate this now and maybe make that a little bit clearer. So if you go down here, you can see the bar scale. It's automatic. And then, I'm going to pick let me pick a busy station here to illustrate this. Zoom in a bit. So if you pick arrivals at Times Square, you can see the bar scale down here. It's automatic. And then when I switch to a station with much less traffic, it automatically changes the scale to make sure that the data is still visible. You can see how much that just jumped up. Otherwise, if I put this back down to how low it was, you can barely even see anything on the screen. And similarly, if I left it up here and went back to Times Square, it would get out of hand pretty quickly. It gets. So obviously, you can see the need for some sort of automatic normalization to make this legible. One more cool thing I'm going to touch on, you have the option to select months down here. So if we look at, our favorite example of commuting, put this back auto, and we compare, let's say, November, you can see the total arrivals around 14,400. If I switch it to a month later, December, you can see that number is significantly lower. And it's kind of cool to try to hypothesize, well, maybe it's because a lot of people are off work the last week of December because of the holidays. So it's kind of cool to see how, cultural or human trends are reflected in the data. So I hope that gave a good kind of overview of our project and the different UI features and functionality. And now I'm going to hand it over to Jediah, who's going to go into more of the tech stack and back-end development of the project. So thank you, everybody.
Cool. Thanks, Marc, for showing us how the project works. I'm now going to talk about what's actually going on behind the scenes. And before I get into the final stack, I want to talk about the process of prototyping, because I think prototyping is one of the most important things you can do in any project. A lot of people have the urge to just dive right into a project and just do it the way they think it'll finally be done and prematurely optimize everything. But that's going to cause a lot of strife for you and waste a lot of time, frankly. I actually, at my job, spent 2 years working on Figma's prototyping team, which basically built tools that allowed people to create high-fidelity mockups. And so while I wanted to make something a little more interactive than that and still use code, I thought it was important to prototype this out before I actually just dove straight into JavaScript code and started making an app. And so I started out by making a Jupyter notebook that just kind of had a really high level usage of what data set we're going to use, what are we going to visualize, what will it look like. And when we started the project, this was just sort of an idea in my head. I didn't necessarily have alignment from the team, this is what we're going to build. I wasn't sure would it even work, did it make sense? And so by doing a prototype that was much faster to build than instead of just jumping right into the app, that allowed me to show this to my team and say, what do you think about that? Do you have any feedback? Can we make something better? And that would save a lot of time, especially in the span of 1 month, which is how long we had for this contest, than just trying to say, let's go straight into it, and then having to pivot really hard somewhere in the middle. So I think that's a really important thing to do for any project, whether at work or a personal project. And so I started out with a Jupyter notebook. I pretty quickly ported that over to Google Colab, which is basically just a cloud notebook thing, so I could share it with the other people. They could run the thing as well. And then finally, when we felt pretty good about the idea, we started moving it over into React and JavaScript, which I'll talk more about later. And so here's kind of a picture of the initial prototype, which looks way more shitty than what the final thing looks like. It's just in this notebook. And you can kind of see the beginnings of what it looked like were beginning to take place. There's the map. It was a light mode. You have the bars. You have in the bottom these widgets, which allow you to change the things. It would basically make an entire new cell every time you change one of these. So it wasn't very good. But this we could see the vision from this. And in order to support prototyping, we leaned on the query API that the MTA provides. It's actually provided by the state of New York, but the MTA has its own contribution of data. And anyone who's interested in working with the MTA's open data or any state open data should really check out this data.newyork.gov. And maybe I'll quickly go and show you what their hub looks like. It's this big website, and they have a bunch of data sets. And for each, this is the one we used. You can see what all the sort of columns are in data set. You can download them. And so they also provide this API, which allows you to literally query with a basic SQL syntax the data. And it doesn't support all the features of SQL. You can't do subqueries and things like that, but you can do group bys and enough to get started. And so this is actually a link. So if I click on it, it's going to open up what gets returned by this, which is this big JSON blob of all these things. One downside of it is it's not very fast. So in the query, whoops, this is something else. In the query, I was getting 100,000 rows here because there's obviously a lot of data, but I just changed this to 500 for the purpose of this for this talk. But if I were to go and change this to 10,000 even, and I guess I have to turn off my browser caching because this is probably cached, it's going to take I don't know, probably 15, 20 seconds, which obviously is not super suitable for a real app, unless your people are really old who are going to use it. So that's not great, but for prototyping, that's good enough. Spending time to make this way faster is going to take a lot of time. Right now, we just want to work on the front end and figure out how's this going to look, what are we going to make. So this is great for prototyping. So I'm not even going to wait for it. It's taking too long. So Yeah, I won't go too deep into the query, but we're basically like filtering based on the user selected values for like which day of the week, which month they've selected, which station they selected. And one thing we don't filter by is the hour. Maybe you noticed when Marc was showing the app, but the hour is like every hour of the day is preloaded because we want you to be able to slide really nicely through the hours and see what's happening over the course of the day. That's like the most natural sort of time span to do. And then if you actually change one of these other values, like the day or whatever, then it reloads. But it reloads pretty fast, actually. And sometimes when you change the destination, it takes a little longer to load. But part of that is just this animation for clarity, really, more than loading time. I'll talk later about how we got the loading time way down. So one other thing I want to shout out when I built this project is, I don't know if anyone has heard of Cursor. Has anyone heard of this AI IDE, Cursor? I highly recommend it. It's really amazing. It is kind of like a better version of the GitHub Copilot that Microsoft offers, and it's an IDE that basically allows you to just like chat with your code base and tell it, please do this. And so like, probably the only way I was able to do something this complicated in the span of 1 month in terms of the engineering was like thanks to this. It just makes it like so much easier, especially for like a personal project that you're not going to keep building on, building on, and building on. I actually use this at work too. Then you have to like be a little more diligent about making sure that it's like writing good code. You know, here the quality of the code doesn't matter that much, but you still need to read it, obviously. And sometimes you can get into a loop of like, I'm asking it to do something and it does the wrong thing, and I just keep asking it to fix it, and then it doesn't ever really work. So you got to be careful. But like, this is just an example of me actually using it, where I said like, instead of bucketing colors discretely, can we make this function linearly interpolate? You know, this is related to the animations, and it said, okay, like this is what you should change to do that, and then it like inputs the diff for me, and I can decide to accept it or reject it, and just saves so much time. So really cool product. So now I'm going to talk a little bit about the front end and the visualization, which in some sense is really the most like complex part of the project. And I'm going to talk a bit about some rendering tricks that I did as well. I was a little worried that like nobody would be interested in that, but then I heard this guy say something about graph theory, and I was like, okay, it's like a good audience who might care. So just in terms of the stack for the front end, so we're using this thing called Mapbox for the map. They're like a company that just provides a map. There's some like open source alternatives to them, but I use Mapbox honestly without really evaluating the other ones because I have some former colleagues who worked at Mapbox before, and they're like really smart. So I was like, okay, it's probably a good thing. And they have a pretty generous free tier. So I was just like, all right, it looks easy to set up. They're kind of like one of the leaders in the space. So I was like, let's just do Mapbox. And I have no regrets from doing that. And then I used React as like the front-end framework. I don't know if we have any like web developers here, but React is just like one of these standard front-end frameworks. What it does is allows you to write JavaScript code that automatically re-renders your app whenever like the state changes. And this is just way easier than trying to like always detect when something changed and re-render it manually. So it just like makes things faster and easier. And then in terms of letting like the map and React talk to each other, there are these two libraries that are pretty much the only two libraries I used, DeckGL and React MapGL. DeckGL is basically a library that uses WebGL, which is like a graphics rendering language to draw things on the map. So that's where these bars are coming from. They're using WebGL to like draw stuff on the map. And then React MapGL is just like a thing that lets DeckGL fit into React-like paradigms so that when things change, it can automatically re-render those bars. So now I'm going to talk a little bit about the animations and how they work. You saw in some of these stories, we have like, we have these animations, of course, and we also have like, you know, these things where the animations are continuously going. And I want to talk a little bit about how that works. So the basic flow is that we have this like animation manager, which is constantly looping with like the next animation frame. So there's some like FPS, like 60 FPS, and every 60 times a second, it's making a new tick. And when the user does something that's going to trigger an animation, like going to a story that has an animation or changing the view that makes this animation happen, this animation manager basically makes an animation plan. And that sounds complicated, but the animation plan is basically just a function which says like, okay, what do the bars look like right now to have a starting point, and like what should their function of time be? Like as the time number grows, like what should the new height of these bars be? So it makes that plan, and then every tick, it calls that function, and it creates a new set of bar heights, which that React to text now has re-rendered, and now it talks to .gl and causes this new bars to get shown. There's actually like a bug in this, which is that you can have this complicated thing where you as the user can affect the height of the bars at the same time as an animation is trying to do the same thing. So like what I mean by that is you can see as I like move around, we have this animation and it's smooth. But I also could go into this like bar scale and now mess around with the height of the bars too. And if I then like try to change the thing, you see it's like has a little tick there. And I'm a perfectionist, but even that I was like, all right, I'm not going to go try to fix that. But if you wanted to fix that, you would have to basically like have some sort of conflict resolution step where instead of having the bar heights be fixed initially when the animation begins, you want it to somehow take into account like where the bars have changed to if the user has changed them. But I just felt like, OK, that's like enough of a bug that even I should probably let it go. So I'm going to talk about how these bars actually are rendered. One thing that you might have noticed is there's like two sort of ways you can look at the map. You could look at it and unfortunately the settings here are making me not be able to close this thing, so I'm just reload. But you can look at it in like 2D or 3D. And the 3D is actually like more out of the box. DeckGL provides something called the column layer, where you literally just say, all right, here's like the positions of my columns and how tall I want them to be, and it pretty much does that for you. I played around with like the light properties of bouncing onto them to make them flat instead of look like actual columns, but it's pretty much just that. The 2D one is a little more interesting because that's not a thing that is supported out of the box. But I really like the 2D view. I felt like it distinguished our project in like a design perspective because 3D is like more common for these things, and I wanted to like keep it. And so the way that the 3D works actually, despite having like no layers that allow you to draw these lines in the map, is it's kind of a hack. I just take this layer that lets you put a scatter plot on the map and put a bunch of circles. And so if you like zoom in really close, where it gets more transparent, you can actually see the circles. There they are. So that's how we do it. And there's actually a problem, which is that especially when you get to like all stations view and there's like a ton of traffic and you have these like a lot of things, you start to render so many circles that your browser gets mad at you and it says this is a lot of objects in memory and I'm going to crash the program. And so that's a bit of a problem. And so to get around that, we did another hack, which is OK, if there's like too many circles, which you can figure out how many circles there's going to be by just doing like a little summation, let's like replace all the circles in the middle with a line, and then you still get the rounded tops. There's no way to make the square round, at least not with going deep into like the rendering code. But just put a square in the middle, and you can't really tell the difference, especially if we make the ones at the bottom like still circles that can fade out. So that is how we make that work. And then something else which is interesting is as I rotate around the map, the bars actually like stay pointed upwards. Which is good because it would look pretty weird if they not only would it look weird if they didn't rotate, but you'd actually be able to see like the circles in a really ugly way. You'd be able to see like through them. And that's also why like I switched to the other view as soon as you go even 1 degree down, because if you go 1 degree down and there's no way really to fix that, like suddenly the circles become like really ugly. And so it's kind of interesting figuring out how to get these lines to stay pointed up. And so the way we do that is basically by like having these two vector spaces, which represent the map and the screen, and projecting back and forth between them. We basically have like two coordinate systems, one which is like the worlds, which is in like a latitude and longitude coordinate system. So that's like the map of New York. And then we have like our screen, which is like in pixels. So a point of that might look like 300 pixels x 250 pixels. And so if I want to find out like what direction I should put, what position I should put these points on the map, because those points are rendered on the map, not on the screen. Where should I put those points in the map so they go straight up? Then what I would do is I'll pick some central point. It's all in New York, so like it doesn't really matter what point I pick, but I pick Central Park because it's a central point. And I say, OK, where does that translate to on the screen? I guess I can just use my mouse. So I say, where does that translate to in the screen? And Mapbox already has like a function that just lets you project and unproject between these two spaces. And so now on the screen, I know this is like 300 and 250 pixels. And I say, OK, let's just like go straight up on the screen, because that's like the direction we actually want to go on the screen. So I'll just say 300 to 249, which is just going up. The magnitude doesn't really matter. I just want the direction. And now I map this endpoint back onto the map. And so now I have like the difference between these 2 points. And that's like the actual vector, which is pointing up on the screen, but in map space. And so then when we're like rendering these bars, we just say, OK, what is this like up vector? And we put it in that direction. And so that's how we do that. And then one other thing which I think is interesting with the rendering, which just goes to show like how all these little things that seem really obvious in a map are actually not. For these stories, when you like pick a story, let's just say like the Chinatown story, you notice the map like changes its view. And it changes the view basically so you can see everything that you are supposed to see in the story. Like in this one, I wanted to make sure, obviously, this like point up here gets in there, and then like the very bottom, Coney Island gets in there, and then all the way in the left gets in there. And so we wanted to figure out how do we make sure that like all the points that should be in view are in view. And this seems like, oh, well, can't you just like set a position of the map and then just leave it there? But the problem is that people are all on different sizes of screens. So maybe like this works for a size of screen this big, but now if I like find someone who's on a phone, I'm not going to make it too small, but someone's on a phone, then like suddenly it gets messed up and this is over here and like it doesn't work anymore. So I want to do this in a way that like no matter what size of screen you were looking on, you would actually see all the points. And I want to stop here for 1 second and just say like with this and the last thing, these are all things that I did because I thought they're fun and like they're perfectionist things, but I want this to not discourage you like, oh, I have to figure these things out if I want to do a project like this. You could just say like, I'm not going to do that, and probably nobody would care. So just like, let that be known. So for figuring out where the map should go based on these points, the easy part is like figuring out what the center of the map should be. The map is defined by like a few parameters. The ones that really matter are like what's the center point that you're looking at, and then how zoomed in is it. There's also like the 3D things, but we didn't really care about that for this. So figuring out the center is easy. You just like put a box around the points that you care about and take like the middle, and then that's the center. What's hard is figuring out how much do we want to zoom in or not. And I was pretty surprised that like there's not just like a built-in function that does this, but there's not. And so you need to like kind of understand a little bit about how the map works and literally how the Earth works to actually figure out how much you zoom. So the first thing you do is figure out like, OK, what's the range in terms of longitude and latitude that I want to be contained inside the screen? And so like the whole New York City fits into like about a 0.5 degree range. I actually didn't even really know how longitude or latitude worked before coming to this, but it's actually just degrees. Like it's just 360 degrees around the Earth, which is way more sensible than I ever expected it to be. I thought it was like some weird thing. It's just like 360 degrees, but they go plus 180 and minus 180. So all of New York fits into like 0.5 degrees, basically. And so you just calculate what's the difference in longitude and latitude that this degree or that this range is. And then once you have that, you need to understand that the way that these maps work, like Mapbox, another one, is they have a bunch of tiles that represent pieces of the map. And Mapbox uses 512 pixel tiles. And so at the smallest possible zoom level, the entire world fits into one tile, which is 512 pixels. And so if we divide that 512 by 360, which is like the total span of the Earth, then we get that each degree of longitude is contained in 1.42 pixels in this like unzoomed out map. So this is 512 pixels. Each like 1.42 pixel represents 1 degree of the Earth. And so now we know how many pixels there are per degree. And so if we just say, OK, there's 0.45 degrees we need to represent, and it's 1.42 pixels per degree, then that means we could fit this entire thing into 0.65 pixels. That's if the map is like fully zoomed out. So now we say, OK, how much space do we have to actually show this story in? And we don't want to put it behind the story or like behind the UI. So we can say that maybe there's like 850 pixels or whatever it is we can measure the screen. And now we say, OK, we have 855 pixels. It takes 0.65 pixels on an unzoomed out map to represent our span. And so if you just divide these things, that means we have about 1,300 times more space than we need. So let's zoom in 1,300 times to make it fit exactly. And then a detail that doesn't really matter that much is Mapbox and all these map systems usually use like a base 2 zoom level system. So instead of you saying, I want to zoom in 1,300 times, you'd say, I want a zoom level of 10, which is just log base 2 of 1,300. And so that's basically what you do. But you have these two axes. You have like the latitude and the longitude. So you just do this calculation twice. You say, how much do I need to zoom to show the entire X range? How much do I need to zoom to show the entire Y range? And then you take the one that's more zoomed out so that you show them all at the same time. And then the one thing I didn't mention is you actually have to like account for the Mercator projection, because if you know about maps, the map actually like skews things up. That's why green looks really big, even though it's not. So you actually have to like do an adjustment for that, but that's not even really worth getting into. So yeah, that was all the rendering tricks. I hope you found those interesting. Probably that's like less relevant to the data folks here, but I find it really cool to like just do all these hacks to actually make things look the way that they're supposed to. But now let's talk about the data part, which is how do we actually fetch the data and get it into the system, and how do we do this in a way that's really fast and not takes like 20 seconds when the MTA API takes that long. So first of all, we could never use the MTA API to deploy this app because they literally say in the terms of agreement, like, our servers suck and you're not allowed to deploy with them. So like, don't do that. So we said, OK, I actually asked on their Google group, but like, please, this is a contest for you. Could I just like do it anyway? And they were like, no. So I was like, OK, fine. I won't do it. So they say, basically, you need to deploy your own server, which is hosting a copy of their data and will serve it to your app rather than just like relying on their thing. This is like just if you're going to like put this on a website and share it with a bunch of people. If you're just like doing this, you know, for yourself and your friends, then like it's fine to use the API. But this is like for deployment. Also, even if I had said ignore them, I think no one would really care. But given that I was sending this to them, I thought maybe they would notice that I had not lied. So I didn't lie. So anyways, I want to talk a little bit more about the data set that Marc showed us. So Marc already showed us like kind of what's in it. It's got a bunch of pairs of like origin station and destination station because it basically tells us like how many trips there are from one place to another. And there are 424 stations in the subway system. So 424 stations times 423 other stations times 12 months times 7 days times whatever. That gets you like a pretty big data set, which is like 14 gigabytes. Maybe in the scale of like businesses serving to millions of people, that's not that big. But in terms of like downloading this onto the user's computer, like we can't just download all the data onto the user's computer. So that was never an option. So we have 14 gigabytes, and we need to somehow like serve it quickly to users, at least in the chunks of like a 1-day range that we care about. And then the like I said, those sort of independent variables. There's some random columns that don't really matter, but the ones that matter are like what's the station we're starting from, what's the one we're ending from, what hour is this, what day of the week is this, and what month is this. Washington Square. So we use SQLite to do the as our database to host this, and I have like nothing but great things to say about SQLite. I think for those of you who don't know that much about different data sets, SQLite is kind of like data set for babies, or at least that's what like experienced engineers will tell you. It like literally just lives in a file, and there's a program that interfaces with it, whereas like more complicated data sets will like have their own server that needs to talk to the database. And SQLite definitely has some limitations. Like at some point of scale, it doesn't really work anymore. And it also doesn't support writing two things at the same time, which for like a real app that has a lot of writes could be a big problem. But in this app, we have no writes. We have a data set. It's fixed. We're reading from it a lot. We never are writing to it. And so like SQLite's perfect for that. We can do as many concurrent reads as we want, but it really doesn't matter that they can't support writing at the same time because we are literally not writing. Some other things that are nice about SQLite are, like I said, it's just a file, so it's really easy to work with. I don't have to like set things up. I can just copy and paste this file around to move the data set around. One like normal disadvantage of SQLite as well is that it's harder to do things like replication, which is where you like have your data set copied to multiple places automatically, so that if your data set gets lost in some way, you can like rebuild it back up. I didn't really care about replication because there's no user data here. If like God forbid I lost a data set, I would just download it again. So like it's not really a big deal. So SQLite all the way. I spend like so much of my job arguing with like these deep infra guys who are like, I was talking to this guy at my job who, has been doing deep infra for a long time, worked at Google before that, blah, blah, blah. And he's like, oh, dude, you got to like do this in RDS. You got to scale up to multiple clusters. I'm like, no, like, why would I do that? I have a 1 month to do this project. I'm not going to like, deploy this in AWS. I'm not going to do these complicated things. Like, I really think keeping it simple makes a lot of sense, especially for like a personal project. I'm a big fan of not prematurely optimizing. I had to learn that lesson the bitter way, rather than because I did it a lot and then wasted a lot of time doing it. Like, unless this is like, flying a rocket into space where it's going to explode and kill people if you like get it wrong, then I would just wait for your thing to like blow up and then realize it needs to be fixed before like trying to patch every possible hole. Of course, this is coming from the guy who like did the bar rotation, whatever, so maybe take what I said with a grain of salt, but do what you enjoy. The guy who said do it in RDS, he probably enjoys doing RDS. So basic overview of how the like architecture works with this SQL database. So we have the user. They're playing with this React app. They change the view, like they maybe change the day or they change the months or whatever. They change something that means we need to get new data. So one thing that we do is a little optimization, which probably wasn't even really that necessary since it ended up being fast to query from the database. But we keep a cache in memory. And basically that just means we like store a big hash map of like some number of previous lookups of data the user has already done. And there's like a, maybe a cap of like 50 on that. And we take the least recently used ones. So when they get old, we just throw them away. And that way, like, if the user is just like going back and forth between like, a couple of views to do some kind of comparison, maybe they want to compare like who's going to Times Square Monday, Tuesday, Wednesday, Thursday. Like, it would be annoying for them to load every single time they want to do that comparison because they're like doing it a lot. So that just stays in memory. It can be instantly, that data can be instantly fetched back for them. But let's say we don't hit that cache. They haven't looked at this specific view before. Then we call this server, which I'll talk about a little later. It's a really basic server. It's using Node.js, which is just like the JavaScript server. And it creates a SQL query based on whatever parameters it got. So React would tell the server, hey, I need the data for Times Square to Fulton Street in January at 6 o'clock, whatever. And then it'll say, OK, here's the SQL query that's needed for that. And then it will read the SQLite database and get that data. And even though SQLite is a separate box, it's not actually a separate server. Just to be clear, like I said before, it's just like a process as part of the server that is reading the same thing. So pretty simple. But later, happy to ask or answer any questions if any of the architecture is not clear. But then, yeah, you get the data, you give it back to the app re-renders, everyone's happy. I'm also going to talk about how we made these queries fast, because just like putting things into SQLite doesn't magically make them fast. And the MTA is not so ridiculously incompetent they managed to like, make their data set or their data take 20 seconds to query this thing, like just because they wanted to hate me. There's actually reasons for that. And so I had to like do some optimization to make it that fast. And so to do that, I had to create something called an index in the database, which probably those of you who've worked with databases are pretty familiar with. But basically what an index is in a database is it's a way of telling the database what fields, what columns in the database are going to be commonly accessed so that it can, like, using some extra memory, or extra space rather, like create some kind of dictionary that quickly allows lookup of those. So let's say, I wanted to make an index of my database that says, I care about the station, the origin station. Then it's almost like I created like a big sorted list of the rows, sorted by their station, and that way I can like binary search through the stations to find them faster. If all that was like gibberish to you, then basically just an index tells the database what fields it cares about. And so I'll talk about the process of building up this index in a way that that matters for our data set, because this actually, this is kind of an easy data set to work with because we are querying, or the users are querying the data set in a really common way. Like they're querying it pretty much the same way every time, which is like, they are going to ask for a filter by day, by station, by months, and like that's pretty much it. It's like doesn't have a really diverse pattern of queries, which would make it harder to like, know what you have to store. So in this case, like I said, these are the main things we want to like filter by. we want to filter by like which day of the week, which station, and which month. And in order to like make our index, we should think about which one of these is going to like which one of these is going to cut our like search space by the most. And what I mean by that is, let's say I know that the day is Saturday, and I say, OK, I can throw away all these entries with a different day. I only have to look at the entries for Saturday. How much should I just reduce the stuff I had to look? Like 7. I cut it from 7-day weeks or 7 days of the week to just 1. So I reduced it by a factor of 7. And I still have to look through like a 7th as much stuff, which is maybe a lot. If I have stations as the main thing I want to like go by, there's 424 stations. So if I have that as the primary thing, then now I've cut the search space by 100 over 1 over 424, which is like way better. And so when I create this index, you can actually like index on multiple things, but in like order of caring about them. And so first I go by the station, because that's 424 stations. That cuts it by the most. And then the day, and then the month. And you might ask why the day and then the month, because there's 12 months and only 7 days. That's because, first of all, you can filter by several months at once. So like, you're not going to necessarily filter it by 12. You might just say, like, I want the first 6 months of the year, and that only cuts in half by 2. And then most of the time, the people don't even touch the months, because the months are hidden below the UI. So like, you should know how users are actually using your data, or how they're actually querying it. And like, it's way more common to filter by a day, which is always being filtered, versus months, which are often not being filtered. So that's why we first filter, or we first index by the station, and then the day, and then the month. So we created these 2 indexes. They increase the size of the database because it takes extra storage to like have this lookup table, but it makes it way, way faster. And then I'm also going to talk about how we did the all stations view, because this is sort of the only case that's a little different. I said everything follows this neat little pattern of like, we filter by the, by the day, by the station, and by the months. But the all stations view is kind of like a completely different thing. In this case, we're basically, if we have just one station, we're saying, OK, like from this one station, who is going here? If we do all stations, we're doing that same thing for every single station. And so it would be pretty inefficient if we had to like just do the thing that we did for one station and then do it 424 times. So we don't want to do that. Like to get a little more precise, before we were saying, OK, for every possible hour and every possible station, like let's say we want to get who is going to Times Square, then we'll say Times Square is fixed, the day is fixed, the months are fixed, but we want to get every hour, and we want to say for every other station, let's get that data. But for this all stations thing, we'd want to do that same thing, but then times an additional 424 stations, like I was saying. So basically, we don't want to do that. So the answer to make this faster is we can use something called the materialized view, which sounds really fancy, but all that really means is like we can just pre-compute the data that we care about and save it in a new table, and then we never have to like do that sum again. Like the point of this all stations view, right, is we want to say for any given station, like how many people are coming from every other station, right? So that's just like 424 queries for every other station, and then we add them up, and then that's like the answer. So instead of just adding them up every time when we want to make this query, let's just like do the entire computation once. So for every station, let's just like take all the other stations, all the other hours, every single point, just add them all up, and now we just have like the answer in a little table. And then if we ever want to get this all stations view, we're just going to query this other table instead. We're not going to do the whole sum. We're just going to have it there ready for us. It's basically kind of like if I had kept a hash table in memory that had this answer. But of course, this is like still a big data set, so we need another data set for it. And something that's cool about this is like this doesn't really cost a lot in terms of extra gigabytes of space, because the original data set is like it has an entry for every pair of stations. This new data set, it already did the sum, so it only has an entry for each station. And so it just cut down the size by like 400 times. So this is like basically negligible in terms of the space. And then finally, I'm going to talk about how I deployed this. And pretty cool, I deployed it for free because who likes paying money, right? So some of my goals for this were, first of all, I just thought it was a fun challenge to deploy it for as little as possible with a nice reward of I don't have to keep paying. I wanted this to live on pretty much forever without me having to worry about constantly paying. And even though if it was probably pretty cheap, I could probably afford it. I don't want to worry about, okay, the credit card went down or got expired, and now I have to realize that and it went down because I didn't renew my credit card or something like that. I wanted it to be free, so I never had to worry about those things. And I also wanted to be insulated from any sort of virality effects, which is okay, if this blows up, I don't want to get hit with an $1,000 bill or something like that. So those are my goals trying to deploy this. I also wanted to do it easily. I didn't want to get super deep into AWS stuff, and yeah, that was pretty much it. So I'm going to talk about how I deployed each part of this. For the front ends, which can be deployed on its own, I use Netlify. I love Netlify. Basically, I used it during development too. It says you can give Netlify a GitHub repo, and then every time you push a new commit to that repo, it'll automatically redeploy your front end. And they have really generous free tier. You have 100 gigabytes of free monthly bandwidth, which means you can basically send people requests of 100 gigabytes a month. And doing the math on that, I think the bundle is loading your front end app is 10 kilobytes or something. So anyways, it's 10 million users who could use this in a month based on these limits. And so I wasn't really too worried. It actually will cut you off if you go above that, but I wasn't really too worried. I'm if we have 10 million users on this, I'll be shocked. And we did not get nearly that many because that's a ridiculous number of users to get for something like this. Probably the most risky thing in terms of cost was Mapbox. Mapbox has a decently generous free tier. You can get 50,000 monthly loads for free. But once you see that, it starts getting expensive quickly. And even though 50,000 is a pretty high number for a month, it would be possible maybe to go super viral and get more than that. And then 50,000 is free, but then 100,000 becomes $250, and then it starts getting quite expensive. And so I wanted to make sure that we didn't do that. And basically the way to do that is, of course, just if you exceed the free tier, cut it off. Unfortunately, Mapbox, they want your money. They don't want you to do that. So they don't give you any way of cutting yourself off. They don't give you a way of figuring out how many usages you've used so far. You can look at it in their website, but there's no API to do that. And so I was just all right, I'm going to track it myself. And so in that server, I just added a file, which just keeps track of how many people have loaded every day. So every time somebody logs into the website, it queries the server, and it says, hey, is there any Mapbox tokens left? And then the server says, yes, OK. Then they're allowed into the site. They can load Mapbox, and then we add a 1 somewhere in the server. And that those ones last 30 days so that we don't just keep growing this list forever. And so that's how I made sure I would never pay Mapbox any money. I also had the ace in my back pocket that if I did somehow pay them money, I could probably beg my coworkers who previously worked at Mapbox, hey, can you talk to them and maybe get me to not pay the money? But I'd rather not even have that conversation. It sounds awkward. And then finally, the biggest hack. So the backend is probably the trickiest part because who would ever deploy a backend for free? You have an actual server and you need to deploy it for free. So I use this website called Fly.io for the deployment. Fly.io is really cool. They're a startup, Series B or something, and they make deployment really simple. Obviously, it's not nearly as robust as AWS. There's a lot of missing features, but really good for personal projects, and honestly, even probably for a production app that's not at massive scale. Some of the cool things they do is they just make it really easy to redeploy your server without having to change anything. But in terms of Fly.io's pricing, again, I wanted to see, is it possible to deploy this for free? And it kind of seemed like I would have to lose out on my goal here because there's pretty much nothing that has a backend hosting free tier. Everything is kind of all right, you're hosting servers, that costs money, you're going to pay us money. So I was all right, can we at least make it cheap? So I said, OK, how much am I going to pay for this? So first of all, you get the main ways that you pay money are, again, bandwidth. Bandwidth is pretty negligible. It's really cheap. That's why Netlify basically gives it away. So that's not really a concern. But the things that are a concern are the literal servers that they're running for you. And the cheapest possible server you can run is this shared CPU with 1 core. And shared means it's a computer that other people's apps are also running on at the same time, isolated with containers. And it's got 250 megabytes of RAM for you. That's like, maybe sounds low, but actually it's like really more than enough for an app like this. Like, unless like thousands of people are using it concurrently, even if a few thousand people concurrently would maybe be okay if it's not an expensive operation. And like thousands of people concurrently is actually a lot of people. That's like, tens of thousands every day. And so I felt like 250 was enough. For the launch, I made it go up a little higher just in case. But I was like, okay, so I'll pay like, $1 to $3 on that. And then the other place you spend money is the data. I have to like copy this big SQLite database of however many gigabytes into their thing, and they're basically hosting it for me. And they charge 15 cents a month per gigabyte. The data set, I originally said it was like 14 gigabytes. After adding the indexes, it got higher, like 20 gigabytes. But then I got it back down to like 11 gigabytes because there's a bunch of useless columns in the data that like I didn't need. Basically duplicated things like what's the location of a station, things that really didn't need to be in there. So I got rid of all those and I got it back to 11 gigabytes, which turns into like $2. And so I was like, okay, the lowest I can go is like $3.97 a month. I'm kind of sad it's not going to like hit my goal, but like, that's pretty good. But then I got hit with this really awesome email where they said, good news. You're not spending a lot of money, so we're not going to charge you any money. We do not collect bills below $5. And so I was like, great. And so every month I get this email. You didn't spend $5, so you're like, it seems like you're poor or whatever, so we're not going to ask you for any money. And so I'm paying no money. So that's great. So pretty much the only place I'm spending money is the domain name. You can't get out of that one, but I figured that one was like a little cherry on top. I could have done it with just the Netlify domain name if I wanted to be free, but I like the domain name. So I spent on that. And then I spent the money on like getting Cursor just for development, but that's not a recurring charge. So that's how I got it to be for free. So overall, if there's any takeaways from like the engineering of this, I would say, first of all, like maps are pretty hard. Sort animations. I would definitely not try to build your own of those things. Definitely don't build your own map. It sounds like a really horrible idea. And also, like, you can probably not go as deep as I did for a lot of these things. Like, I didn't need to rebuild these animations. Like, you can probably just, ignore those little things and use everything in the box, and no one will be mad at you for it. Another thing is, this is like a lesson that I learned a lot from my company, Figma, which is that historically, people put like all the business logic of an app on the back end. They're just like put everything in the back end, and the front end just like does as little as possible. But if you want to make a really interactive app that feels fast and sharp and is a beauty to play around with, consider putting more things on the front end. Front ends, people's computers are pretty fast these days. You can put a lot in there, and the best part about putting stuff in the front end is you're not paying for it. They're paying for it, so that's great. Make your users pay for your app. And then finally, my last point is keep it simple. Like, I think things that are looked down sometimes as small scale, like SQLite, like Fly.io, like Netlify, like this can actually take you really far. You read like these blogs from like Google or Facebook or whatever, and they're like, oh yeah, we had to like vertically shard our database onto like 1 billion clusters. Like, you don't need to do that. Like, you really don't. Like, maybe for your job you might, but actually, unless your job is serving like millions of users every day, you really probably don't. Like, you should try these smaller things first, especially for a personal project. If you're like not doing a personal project because you think you have to like shard your database, then like just do a personal project and don't do that. And if it fails, then like, dang, that sucks. But like, it probably won't. So just don't do that. So that's all. And finally, the thing's open source. I don't have a good README up there. I should really do that. But you can check out the repo and see all the parts I talked about in there, mostly in the client, like I said, but you can see the server too. And so I hope you check it out. And that's all we have for you. So thank you, and happy to take any questions.
All right, cool. Questions from the room before I do any virtual ones? Any questions? Right here. First. Please repeat the question so people get it.
Yeah, totally.
If one sees this, like, it doesn't seem like that complicated, but when we get into it, at least for me, it's kind of, okay, this is kind of complex. How did you as a team get to a strategy in which you could like get all these pieces and put them together and make this work in so small span?
Yeah, that's a good question. I mean, again, one thing I'll say, yeah, so the question was like, basically we had a complicated, it's a complicated app. How did we like put all these components together and how did we do it in such a short time frame? And the first thing I'll reiterate is like, this is in some ways overcomplicated. Like I said, keep it simple. I kept it simple in the things I didn't care about, and then I overcomplicated the things that I had fun with. But you don't need to do that. So like, you could get rid of a lot of the complex, animation and rendering things, and it would probably, be 95% as good, and like that would be fine. So you don't have to do that. And then in terms of like how we actually did it, honestly, I would say like a bit of good planning and a bit of heroics. Like the heroics being like, and luck. The luck was that I was like in between like work at my job at that time, and so I had like more time to spend on it, and so I was able to just like spend time on it, and I had a lot of fun doing it. I didn't tell my boss that I was doing it, obviously, and so that helped. And then in terms of fitting together, I think like we did, like it was planned pretty well in terms of like making things modular. Like ultimately, trying to like make the components like fit together in a nice way. Like for the backend, right? Like we started out with this MTA API like for 95% of the way, and then we just were able to replace that with a server at the end when we realized like we needed to do that. But like it wasn't like super weaved in such that it was really hard to untangle that. It was like everything was pretty well separated so that we could just like fit things together and plug that out. But then like the other thing that really helped a lot again was like cursor, because if I had just write this all from scratch at a time, probably wouldn't have been able to do it. But if I just say, hey, do this for me, then like it becomes way more manageable too. So yeah. Yeah.
Was this something you always wanted to compete in? How did you pick who to work with?
Yeah, that's a good question. I mean, this was the first time they did that competition, but I was really excited when I saw it because I'd wanted to do some sort of MTA contest for a while, because they had done like some sort of hackathon years ago that I hadn't heard about, and I had a friend who had competed in it, and I just thought it was a really cool thing. And then both of us, me and Marc, are native New Yorkers, and so like it was pretty personally meaningful to do a project like this. We didn't know in advance what project we wanted to do, but we saw what datasets were available and found something. But yeah, we wanted to do something that like told the story of people in our city, and like as an experiment, tried to figure out what would it mean to combine the insights from data with like personal narrative, which is like the stories, which we didn't even get too much into. And we did that partly because we felt like right now we have this problem where like there's a lot of stories out there which are really compelling but aren't true, and a lot of data which may be true but like nobody cares about it. So like, how do you make people care? So that's kind of the thing we were trying to answer. Does that answer your question? Yeah. Yeah.
Great talk, super creative. What kind of traffic are you getting?
Yeah, the question is, what kind of traffic are we getting? I think, yes, we never hit the 50K MacBots limit. I think at the most we got like somewhere in like the 10s or 20,000s range in the first month, which I felt was pretty good. Sadly, someone apparently posted it on Hacker News. That person was not me. And then we got like our biggest day, which was like almost 10K in one day. And then it actually broke, and not because of any scaling issues, but because of like some like little bug in the server. And then I only realized a day later, so I was like, oh, damn, that's too bad. But yeah, so that's about how much we were getting. And now I think probably consistently it varies, but anywhere from like a few dozen to a few hundred a day, which like is easily handleable by the infra. Yeah.
A virtual question. Vikram actually asked, what did you use for the LRU cache? Was it a service, or did you?
Oh no, I think using Redis or anything like that would be like super overcomplicated. It's literally just like a hash map, and you just delete things from it when it gets full. In the browser, like in the client, yeah. It wouldn't be in memory if it was in the server, or I guess yeah, then it would be in memory in the server. But yeah, SQLite's fast already enough for that.
All JavaScript.
Yeah, well, I mean the server is JavaScript too, but yeah, all that LRU cache is all just in JavaScript, and it's not that complicated. Well, I actually asked Cursor to write it for me, but even if you wanted to write it yourself, it's not very complicated. You just keep like a set, and then you increase, or like I guess you have an ordered set, which I think JavaScript already has, and then whenever the number of stuff inside it gets too big, you just look at the last thing that was added, and then you delete it. So yeah, over there.
Amazing project. Did you have any feedback from companies or people that saw like some economic value in this, like real estate developers or restaurant owners? I don't know.
That's a good question. It was, did anyone come to us with like, ideas about economic value of this or something like that? I mean, there was no one who was like, hey, like, we want to buy this from you. That'd be cool. Definitely, like, we'll take offers, but definitely, at the beginning, we thought of it in terms of, well, it's a creative project, but like, we also thought it could be useful, especially the explore mode for like, businesses, for example, if they want to figure out like, okay, what time is like peak traffic to my neighborhood and where are these people coming from? Maybe I can try to figure out those demographics. So things like that could be cool. We never really like deeply explored what that would look like because we'd need to, I guess, like get in touch with people who'd be interested in using it and figure out that. I think it'd be really cool, and like with more time, I would like to. Or if someone is like, hey, I want to use this, I would like totally welcome that and like help them do it. But yeah, it's not something we like super deeply explored.
Well, thank you. Now, from this standpoint that you've already done, finished the work, is there something that you would have done differently?
Something we would have done differently. That's a good question. I mean, some of these like more complicated things, like I probably didn't need to do. So I think like that's maybe the main thing. It's like, okay, I could have like not spent so much time doing those. But I don't really regret them because it was fun and I had the time at the time. Maybe one thing, which is like kind of a small thing, is I do regret doing it in a Jupyter Notebook at the beginning instead of just doing it straight in Colab, because Jupyter Notebook is like harder to share. The nice thing about Colab is like you can give it to non-technical people and they can just like play it, whereas the Notebook is like they don't know how to run it. And so I just had to like do a little work to like move it over from Jupyter into Colab, and I wish I'd just done that in the beginning. Yeah. Yeah.
You mentioned you also had a design collaborator.
Yeah, Julia.
What was their role and how did that play out?
Yeah, so he asked about our design collaborator, Julia. So Julia helped with a lot of the visuals of it. Like you saw how ugly it looked at the very beginning, if you remember that slide. Like this is what we started with. And so Julia's like a professional designer and like, first of all, makes things look good professionally, but more than make things look good, she also thinks about how, people should use the app, like where things are placed and like what like the way, what makes things most, how to communicate things, like what sort of wording is clear. Like, some of it was complicated in terms of like, what are we actually looking at, especially with the fact that like it's a 2-dimensional data set. It's not just like how many people are here, it's like how many people are coming from here to here. So she was a big help in like thinking of those sort of things of like, what sort of wording could we use to make that clear? Like I had written as, where are they coming I said coming from or going to, but then like she was like, that doesn't make any sense. Like, are they coming, like where are they coming from? Are they coming from the station, or is it like asking where are they coming from? Where are they coming from, or are they coming from the place? So it didn't make any sense. So arrivals and departures made more sense, things like that. And then yeah, also she just made it look super great by helping with the components, and she did a lot of designs in Figma, and then I took those and translated them into code. Any last questions?
For Mapbox, we're using it just to get like the background tiles, or we're using it for something else?
I mean, Mapbox is like pretty much plug and play. I'm just like, hey, let there be a map, and then there's a map. And yeah, so like I didn't really have to think about any of the details except for that like one thing of like the zooming. But it, I just say, here's my map component. It makes a map. I can tell it where to zoom and where to be and all those things. Yeah.
I guess we're using DeckGL to use Mapbox, or?
So DeckGL is for the stuff on top of the map, like the bars. Like even the tooltips are not DeckGL, because those are like on the screen and they like move around with the screen. But the stuff that actually like moves with the map and stays in the map, that's DeckGL. And so yeah, that like allows you to render shapes on top of the map. And then like it also, you can actually literally write GL code, but I don't know how to do that and I didn't really care to learn. So it has like these nice out of the box like columns and things like that, and not bars, which is why we did like the hacky things. Yeah.
Yeah, we have time for another 1 or 2 questions. Anyone have a last question? One last time? No? Oh, all right. You put your hand up.
Sorry. What was the hardest thing for you when developing? I mean, in the whole project, not only developing the app.
The hardest? Honestly, the non-technical part of it, which was like making the stories and making the interviews. Maybe
Yeah.
Marc, you want to talk a little more about it?
Yeah, so I didn't have time to go into all of the stories, but one thing we were proud to include was we had an interview in every story, which was kind of somebody firsthand, kind of helping provide some context for what we saw in the data, and that was something that we felt added a really nice human touch and kind of also validated what we were seeing in the data. If we'd had more time, I think time was also a challenge in this project. Ideally, we would have liked to have 2 or 3 or even 5 interviews for every story and really kind of build them out as more complete journalistic pieces. But that was challenging, kind of getting all of that together in time, looking good. Yeah. If you have anything to add.
Yeah, no, totally sums it up. Well, if there's no more questions, thank you all again for being here, and thanks to Jared for hosting.
Yeah, thank you.
All right, folks. Thank you very much to our speakers. That was excellent. I had really enjoyed it. Hope everyone else did. Are you two coming to the bar so you can ask more questions?
Yeah,
I'll come for one drink, yeah.
All right, cool. So before we all head to the bar, remember, next month is Vikram. April is either going to be Eric or Garo. And May is either going to be Eric or Garo. And then June, I think we have someone tentatively scheduled. Maybe July, I don't really know. Am I missing any announcements besides that, Nicole? Did I forget anything? All right, so we're going to Malt House. Thank you to NYU. Thank you to our speakers. Everyone have a great night. See you next month. Thank you very much for
Thank you guys for coming.
Take this off.
Yeah. All right, thank you.